Hello everyone, Doug Simonian over at New York Metro Weather with your latest video discussion. This video is primarily going to be focused on the upcoming potential snow event for Saturday night into Sunday morning. It's going to be a tricky system to forecast because the pattern is pretty progressive and fast moving from west to east, but there are also some features to the pattern that could try to amplify it to cancel that out. So you almost get a little bit of a seesaw effect where if the amplifying effects take over, like the fact that the main ridge is well off the west coast, then the storm could quickly become more amplified and turn northward along with the departing area of high pressure and make it a warmer system with less snow and more rain. But then if the faster features come into play a little bit stronger, then the storm system could actually slide more west to east and miss to the south. And then also a more subtly weaker storm would mean the storm itself would not be able to generate a lot of cold air, so any light precipitation would also be in the form of rain. So we're really trying to thread the needle, so to speak, between the amplifying features and the fast and progressive features. But if this needle can quote-unquote be thread and you get that proper balance between the fast-moving features and the amplified features, and this could actually become a pretty significant snowstorm across much of the DC to Boston area with the potential for 6 to 10 inches of snow possible. So we'll look at, this is the today's European model. This first image is at 500 millibars from the WSI Model Lab, valid for Thursday evening. We see the main shortwave responsible for the storm is, at this point, still over Alaska and northwest Canada, where the data regions are somewhat sparse, so the models are not going to have a great sampling of this piece of energy, which means they're not going to be forecasting it too well. And this is important because this piece of energy crashes into the west coast of North America, and well, more so the US anyway, Friday afternoon into Saturday, and then amplifies as it heads into the middle of the country and phases with some leftover southern energy. So if the models are having trouble picking up this piece of energy, that means they're going to be bouncing around with their solutions. But on the progression, we see that it's a pretty strong area of vorticity, very high vorticity values. And the pattern is still pretty zonal, though, as well, from west to east. However, look at this main ridge axis as well off the west coast, and there is a southeast ridge as well, which also, from a pendulum perspective, ridge well off the west coast, southeast ridge would mean amplification and the storm going north. But the fact that the pattern is in the U.S. itself is still somewhat zonal from west to east. And there also is a little bit of a brief confluence and blocking feature with a vortex south of Greenland. That also would help to counteract that and maybe keep the storm a little bit further south. But anyway, we see that the storm, as it enters this central plains on Saturday morning, is able to raise the heights in the east, allowing for some amplification, but not to an extreme amount, so where the storm becomes a rain event. You also have the tropospheric polar vortex somewhat lining up, at least on its western side, along with the shortwave into the western part of the shortwave, which means it's not really pressing down and inhibiting its development. If this polar vortex were to dive further south out ahead of the storm and not phase with it, then it could become more of a hindrance to its development and shear it out like the GFS, and we'll get to that shortly. But either way, the ingredients come together very nicely, and we also have a southern stream and Gulf of Mexico connection with moisture being tapped in for a potent shortwave to move from the Ohio Valley into the Mid-Atlantic into the Northeast, resulting in a quick hit of moderate to heavy snow across the region on Saturday night. We can look at the surface. We see that on Saturday morning, we get a quick shot of cold air behind the warm surge on Thursday and Friday. See this nice area of high pressure moves in that provides northerly winds and colder air as the main moisture axis and low pressure develops in the Tennessee Valley and in the southern states. And we see that as it taps into more Gulf moisture, see the southerly flow along the Gulf. You increase the temperature gradient along the eastern seaboard with that moisture being advected into that gradient. So this impressive gradient with the moisture convecting into it allows for a blossoming of precipitation heavy at times in the mid-Atlantic, and we already see some heavy snow moving into DC Saturday afternoon, Saturday evening. And then the storm intensifies off the coast with a blossoming of precipitation and moderate to heavy snow across much of our area on Saturday evening and Saturday night, and ending as a band of snow Sunday morning across much of the area before the storm departs, and getting replaced by more warmth. So it's a very quick-hitting system that times itself perfectly with the quick shot of cold air that we have. Notice the area of high pressure departs, and the winds actually are initially easterly and southeasterly, which we will have to monitor as well for any warmer trends with the storm. But still, the European model is pretty impressive. Now let's take a look at the GFS model to show a more suppressed solution. We see the same piece of energy enters the western U.S. It's a little bit weaker than the European models, but somewhat impressive. But look what happens. This piece of the tropospheric polar vortex is kind of diving a little bit further southwest and ahead of the piece of energy from a longitude perspective. And what that does is it provides increased angular momentum at the point where there's more compressing and beating down on the storm itself. So it becomes more sheared out and less impressive. Look how sheared out the wave becomes because the polar vortex presses on it at 72 hours. Whereas on the European model at 72 hours, it's more so north and out of the way, and it's not diving south. The western lobe is not diving south. Here, the western lobe is diving southwestward and compressing the shortwave. Also, the southern energy that phases into it is very sheared out and almost unnoticeable. So the whole wave gets sheared out and disorganized, so it ends up missing to the south. That is a GFS bias, though, to overly shear out southern waves. So I do tend to lean against the GFS. I don't see the storm getting completely shred out and out to sea. However, the European model, it's not perfect. I mean, it's generally more accurate than the GFS, but we want to be careful to say, oh, European is right and GFS is wrong. But I just don't see how the southern stream energy is going to get that sheared out. And I think the GFS is probably overdoing its polar vortex intrusions. Like sometimes it digs down northern stream energy a little too aggressively. However, with the pattern being so zonal and west to east with this tight compressed gradient, I mean, you have 588 decameter heights throughout central Florida and almost in the Gulf states, and then you have a 574 decameter polar vortex. So there's a very strong height gradient, which, yes, it means there's a temperature gradient for a storm, but sometimes the gradient is in the heights are too strong, so the flow is compressed. There's not a lot of room for amplification because it's so zonal and so fast. So that means a GFS cannot be completely tossed, but it is a much more weaker and suppressed and sheared out wave. So that's also something to keep in mind. Let's take a look at the latest NAM model. We see it has the piece of energy very potent as it enters the Pacific Northwest, more along the lines of the Euro. And we see this initially strong southeast ridge to help provide some amplification and a moisture fetch into the storm as well. And the southern energy that phases into it is a little bit more organized, and as a result we see a very potent and organized shortwave with warm air advection out ahead of it, but just enough lingering high pressure to provide cold air that leads to a snow threat from the system. And the NAM is actually a perfect balance between a fast west to east flow to prevent an amplifying shortwave in the plains from cutting to the north, but also enough amplification from the southeast ridge and the shortwave itself to keep it organized without the compression to the north to really suppress it. So there's a good balance of amplification and zonal flow to keep it from sliding out to sea. But again, that's a pretty tough, delicate balance. There's not a whole lot of room, so to speak, to lock in this confluent feature. See, the flow in the Atlantic is still pretty fast at this point. So this is what we call a 50-50 low that keeps the height field a little bit more compressed in the Atlantic, that keeps storms further south. this feature could easily slide out to the north faster because there's nothing really stopping it. However, if the timing is right, this shortwave will be aligned enough with this feature to where it still will act as a sort of blocking mechanism to keep the storm south. So there's not a lot of room for error, but there's a little bit of room for error thanks to these transient features in the higher latitudes somewhat aligning with themselves to keep the pattern from becoming too amplified, as well as providing a nice temperature gradient for a moisture surge. So we can look at the NAM at the surface. We see the area of high pressure that moves in to provide the cold source on Saturday morning. And we see the precipitation surges very nicely, and the low pressure moves into the area of cold air. And yes, the high pressure is sliding offshore, which leads to some easterly flow. However, this time of year, in February, mid-February, the ocean is a little bit colder. So for a snow perspective, we can afford some onshore flow without it getting too warm. And additionally, the surface flow becomes tight and it becomes stronger. So if you have a stronger surface flow off the coast, remember that the pressure gradient force says that air flows from high to low. So if the air is going to flow towards the low, right, and the low is stronger, you get a stronger pressure gradient force, and you're able to maintain more north and more northeasterly flow as a result of the high moving air, the air from the high pressure moving to the towards the low pressure. Additionally, with a stronger low pressure, you get more of a counterclockwise flow in general. Look at the isobars; they're closed and circular, and a lot of times the wind will follow those isobars. And we also see the isobars hanging back from the high pressure in a northeast to southwest fashion, thus northeast flow. So that's able to keep the temperatures colder despite the high pressure sliding offshore, and you're able to get a widespread heavy snow event on the NAM model. This would easily be a 6-inch plus snowstorm for the DC to Boston corridor if this were right. Really a beautiful snowstorm depicted from a meteorological perspective. But of course, with the fast-moving pattern, if the low pressure is a little bit weaker and more broad in its contours and its isobars, then you're not going to be able to generate that pure northeast flow. We could take more of a look, a zoomed-in look at the surface winds on the NAM. Right, we see, look how the winds turn northeast even along the coast, despite the high pressure sliding offshore. See, they turn northeast. Why? Because the low pressure becomes stronger and the isobars are very tightly surrounding it. So you get counterclockwise flow into the system and northerly winds maintaining cold temperatures. And you also get a strong storm system leading to heavier precipitation, which also helps to cool down the atmosphere. But if this low pressure were weaker and more broad, then you'd get more just pure easterly and southeasterly fesh. See, when the isobars are not as tight, the high pressure's wind field takes over and you get more easterly and southeasterly winds, and then it becomes warmer. So that's also something we have to watch for. A stronger coastal low will be better for cold and snow purposes, and a weaker and more broad coastal low, even in the same spot, would actually lead to more warmth from the high pressure. And that's also something we have to keep in mind, that just because a low is off the coast doesn't mean it's going to be cold for snow, especially with the high pressure sliding offshore. Another interesting fact to look at on the NAM model is that there is a direct Gulf of Mexico moisture surge. Look at the precipitable water anomalies on Friday afternoon with the gradient from the high to the gradient that the high pressure depicts from a dry air and moist air perspective. And we see that this moisture surge from the deep south actually gets fed into our storm system in the Tennessee Valley and in the Mid-Atlantic. And that leads to a high amount of moisture being depicted into the storm system, which is why we could get some moderate to heavy snowfall rates if the NAM were to be correct. We also see a strong jet streak along this gradient. So the right entrance region of this jet streak will lead to a blossoming of precipitation. And this jet streak is also compressed in the west to east fashion, which prevents too much amplification, but it is amplified enough for a low pressure to form along it. Notice how, see, this jet, because of this somewhat of a kicker disturbance in the northern plains, gets pushed to the south and east, which prevents too much amplification. That's why this the pattern being fast flowing is pretty important to counteract the southeast ridge. But if there is no southeast ridge, then this progressive kicker feature would shunt the storm too far south. So it's a balancing act, as I said before, between the southeast ridge and the progressive west to east pattern. But without either feature, the storm would not be able to form at all. But the jet streak is still very potent off the coast as it moves eastward, and you get a right entrance region right off the mid-Atlantic coast for a low pressure and a period of moderate to heavy snow on the NAM model. We'll take just a quick look at the long range. I mean, with the storm, with snow threat 4 days away, this isn't the primary focus right now, but next week, there could be a very strong southeast ridge and record warmth. This is per the GFS ensembles, maybe even approaching 70 degrees. But notice in the high latitudes towards Greenland, there's more ridging and blocking moving in, which helps to suppress the height field and this elongated area of confluence in a vortex off of Newfoundland and into the Atlantic. What that does is compress the southeast ridge over time and provides gradually more cold air and a nice gradient for storm threats. So we may be talking about snow threats once again to close February and enter March, because as this, look at this vortex that's just being locked in. It's not even moving. It just becomes more closed off, elongated, and stronger to suppress the southeast ridge. But with this somewhat of a split flow, you get a lot of impulses coming out of the southwest, riding along the periphery of the suppressed southeast ridge, and it's being forced to stay to the south thanks to this blocking. So that could lead to more snow threats, potentially bigger snow threats if this block were to materialize from late February, and more so especially early March as the pattern really becomes blocked up. And this trough in the west just sends out multiple disturbances, ejecting eastward into the plains and into the mid-Atlantic, providing snow threats. But this is, again, that's a pretty long ways away, and sometimes these blocking patterns are not all that cold, but and with the trough in the west, it does give room for there still to be a little bit of warmth to where you can't guarantee all the threats would be snow threats. But with this type of block being depicted, that tends to lead to just enough cold for snow. So that is something we'll have to monitor moving forward, and the pattern will certainly support some bigger snow threats to open March across much of the northeastern U.S. So we hope this video was informative and that you enjoyed it, and we will be sure to be continue tracking the snow threat over the next few days. So have a good evening, and we will talk to you guys soon. Take care.